Calculus, Unit 1, Day 3 notes. Our objective, evaluate limits analytically, including direct substitution, cancellation, and rationalization, applying the properties of limits. Okay, so I have a function f of x that is equal to 1/2 the absolute value of negative 2x plus 4, and then subtract 4. So consider that, and they have that on the graph. And we want to come up with the following limit. So what I'm going to do, I'm actually going to do the right-hand part of the this table first. So first one we want to find, and you guys can see it, but as x approaches 0. Well, I see right here, as x approaches 0, as I approach x from the left and x from the right, it looks to be approaching negative 2. And when I substitute that in and I find f of 0, negative 2 times 0 is 0, plus 4 is 4, the absolute value of 4 is 4, times 1/2 is 2, 2 minus 4 is negative 2. Hey, f of a equals the limit as I approach that same value. Right, the next one is as x approaches 2 from the right. So here's 2 right here, and I'm only approaching it from the right. So this one-sided limit is negative 4. And let's check what I get when I put it into f of a. Again, those two we just found. That was supposed to be negative 2. Sorry about that. I did that a couple different times. There you go, negative 2. All right, so now, checking this one. So negative 2 times 2 is positive 4, negative 4 plus 4 is 0, absolute value is 0, 0 times half is 0, minus 4 is negative 4. So those are equal. Next one asks me as x approaches 10. Well, that's off the graph. This keeps going up here. We'll say 10. So it looks like it keeps going up, up, up. And this value looks like it's going to be, actually be probably up here. It looks like it's going to be at 4. So when x is 10, we're going to get 4. Let's substitute in negative 2 times 10 is negative 20, plus 4 is negative 16. Absolute value of that is positive 16. Half of that is 8, minus 4 is 4. So what did we just find out? Well, as long as the function is continuous at that value, x equals a, then the limit of the function as x approaches a is equal to the value of the function at a. So this is going to be very important going forward. So if I know it's continuous, I don't have to worry about the limit anymore. I can just say, hey, that limit as it approaches that is just the value if I do direct substitution. So why don't you guys take a second to try a through f, and then we'll go over these, and I'll give you a chance to look at those. All right, let's see how you did. So find each of the following limits analytically. And hopefully you noticed I have to, again, check each one to make sure as x approaches a that at that value it's continuous there. If it's not continuous, then then the limit might not exist. And it can't use direct substitution. But if it's continuous there, then I can just use direct substitution. So again, a quadratic is always continuous, so I just use direct substitution, we get 1.5. Here I see this rational function. I see that 3/2 will make the denominator go to 0, but it's saying as x approaches 3, so I'm good. Substitute in, we get 17/5. The next two, this function, I see that x cannot equal negative 1. That makes the denominator go to 0. And also, I should do x is greater than, less than negative 2, because that'll make a negative under the radical. But x approaches 2 from the left, that's okay. We're looking for that one-sided limit, so it's neither of these were okay. So I use direct substitution, sub in 2, and we get 1/3. No restrictions on a sinusoidal function. Sine of 2 theta, substituted in, sine of pi is 0. And the last two, a little bit trickier. Here I know theta can't equal 0. It's not. It's going to be 2 pi over 3. So just substitute in. Cosine of 2 pi over 3, which is 120, is negative 1/2. Dividing a fraction by a fraction, we multiply by the reciprocal. Negative 1 times 3 is negative 3. 2 times 2 pi is 4 pi. And then here I can't have log base 8 of 11 minus x. I can't have a negative value there. So as long as x is less than 11, and they told me here that it's going to be approaching 9, so I can just do direct substitution. And again, 8 to what power equals 2? That's 1/3. Okay, so that's going to be part 1 of the day 3 notes.